Okay, this is my second video because the other one ran out of time on it. I'm now going to describe an oxygen molecule through the respiratory system and using this diagram here. Okay, so firstly the body has to breathe in for any oxygen to enter it. Now the oxygen will either enter through your mouth, where I'm pointing here, or through your nasal cavity. From there it will pass down into your pharynx, split from either your esophagus or down to your trachea. Obviously you do not want any food going down into your trachea, so there is a small flap of cartilage positioned around here which will help prevent any food from going into it. The oxygen then travels down past your larynx, also known as your voice box, and then heads into your trachea. The oxygen heads down through here and then splits off into two separate areas called the bronchi. This heads towards your lungs. From there, just before they reach your lungs, they will split off again into even smaller branches called the bronchioles. After this, the oxygen molecule will travel into the lobes of the lungs, and from there will be diffused through the alveoli. This is the process called gaseous exchange or diffusion, and allows us to live every single day. It is very important because it allows our body to have the oxygen needed for our organs and our muscles to repeatedly work. And finally, the last two things was the case studies. I'm not going to read through the entire case study again. I'm just going to pick certain things out and add on the appropriate things which I have found. So firstly, the cardiovascular case study. More oxygen nutrients to be delivered at a faster rate is good because the oxygen is being used to provide energy for the muscles. So obviously the more oxygen which is in the body, the more energy for the muscles, meaning Mo Farah can work at a higher intensity for longer periods of time, which all helps with his training and will all lead up to the big event, the Olympics, meaning he can excel further at that given. Also an advantage for vasoconstriction is it occurs when receptors in our body send impulses to the arteries and arterioles leading towards the muscles, telling them to constrict. So for example, the digestive system, Mo Farah will not need that as much as his gastrocnemius muscles, so there will be less blood going towards them. Also, another function of this system is that it is able to protect the cardiovascular system, is it is able to protect the body from illnesses. It does this by white blood cells or leukocytes also travelling along in the bloodstream to the muscles and organs. From there, they manage to help fight against any toxins or foreign bodies found. So obviously if you've got a cold, it will help fight against that. It also helps with the clotting of the blood, which will help prevent any significant blood loss through any open wounds which may cause bleeding. This is all helpful towards Mo Farah because it means that his body is able to fight off illnesses or bacteria which may cause harm to his body. Without this happening, he may have to miss training due to being ill or not being able to train at a suitable intensity, which all of this could hamper his chances of performing when approaching competitions, which could have an effect on whether he is selected to be. Finally, another function of the cardiovascular system is thermoregulation. This is where the body exchanges heat between the tissues, organs and skin to maintain a certain internal temperature. A typical example of when you would see this occurring is when exercising. This is due to the frequent contraction of the muscles in the body. Where Mo is running, his leg muscles, so his quadriceps, his hamstrings, his gastrocnemius, they are all contracting. This will cause the temperature of your body to increase. So in order for it to maintain at the same level, the body, or the same temperature, the body will begin to do several things to help. Firstly, Mo would begin to start sweating. This is because it will help maintain a healthy body temperature. Just help maintain a better body temperature. However, a disadvantage of this is that Mo will start to become dehydrated because of the loss of body fluids. So this is bad because it will cause Mo to become more fatigued over a period of time, or if a significant loss of sweat occurs. So therefore, before racing, it is important that Mo is well hydrated so that he can balance out the loss of fluids in order for him to perform at the level he wants to and his coaches want to. Also, your skin will become red or flushed when exercising at a higher enough intensity or for a long enough period of time. This is because the body is circulating the blood closer to the surface of your skin. This is to keep the internal temperature at a normal level, and also having the heat close to your skin will help cool down your body. It basically helps as well keeping vast amounts of heat away from your internal organs so they are able to function normally. Obviously, if Mo Farah's lungs were to start overheating, then he's not going to be able to get in suitable amounts of oxygen within each breath. Again, all of this affects how well he is going to be performing in his race. And finally, I'm just going to be talking you through the various amendments I made for my respiratory case study. So, firstly, I'm going to be talking about inspiration and expiration. Inspiration is where we breathe in to draw more oxygen into our lungs. So in order for this to happen, our thoracic cavity must increase. To do this, our intercostal and duct muscles and our diaphragm must contract. This basically flattens the diaphragm and pushes the rib cage up and out. So here you can see all the internal intercostal muscles, and here is where the diaphragm would sit neatly in between the ribs. This will push up, so expanding these out, allowing more air to flow through into the lungs. All of this helps because it means more oxygen can enter our body. This can then be diffused through the alveoli and supply the body energy through the bloodstream. All of this results in Mo's body being supplied with a continuous amount of oxygen, meaning he can train and race at a higher intensity compared to if the thoracic cavity didn't expand. Also, expiration. This is where the diaphragm relaxes along with the internal, along with the intercostal muscles. This decreases the amount of airspace in the thoracic cavity, which causes all remaining air to be pushed out of the lungs. This is done by the intercostal muscles and diaphragm relaxing and returning to their original position. So again, it's been pushed up, it's all expanded, it's then relaxing and contracting back down, so the airspace is getting smaller in between the lungs. This is good because it means Mo can exhale all remaining air so that he can then breathe in a fresh supply of oxygen. It helps because obviously if you've got remaining carbon dioxide which is left within the lungs, he wants to get rid of that. So this process again helps with getting rid of any unwanted CO2. This means again it can be replaced by oxygen. Therefore this allows the muscles to be supplied with oxygen, giving them more energy to contract. again, it all results in meaning Mo can work out at a higher intensity, which will make him perform at a higher level. I'm now going to describe different types of lung volumes. When running, Mo's lungs can hold a differing amount of air, or even when he's just resting normally. This depends on how deep the breath and the pace in which he breathes. So here are some examples of different volumes. The main types I'm going to describe is tidal volume, the amount of air we breathe in or out in each breath. Vital capacity, this is the maximum amount of air you can breathe in or out in one breath. And finally, residual volume, which is the amount of air left in your lungs. All of this will help Mo because, again, he will be able to breathe in more oxygen, supplying the muscles. But continual training of this, so constant aerobic fitness, which Mo is doing, will improve all three of these. Another way you can measure it is also by your VO2 max. Now, for runners and various other people, they will constantly test this. But again, frequent training of aerobic fitness will mean that Mo's VO2 max will increase, meaning that all three of these will increase, so he will be able to have more air within each breath, meaning more oxygen gets into his lungs in each breath. Also, more air can be breathed in and out in one breath, again meaning more CO2 can be exhaled as well. And finally is breathing control. This is done by the medulla oblongata in the brain. It is also done by the chemoreceptors found in the main arteries. It monitors the levels of CO2 and oxygen in the body. Therefore, the chemoreceptors will detect if there isn't enough oxygen getting transported to the muscles. Therefore, this will send impulses up to the medulla oblongata, which will tell the brain Mo needs to either breathe in more frequently or breathe in deeper breaths. This will all help or hopefully supply him with more oxygen, and again means his muscles have more energy to contract more readily and forcefully, all improving the intensity he works at, and all improving the bigger picture, his Olympic goal. That is all for today. I hope you enjoyed listening. Sorry it was a little bit long, but I couldn't have it any shorter. Cheers.